Hello class, and welcome for joining me in this video short, where we are going to discuss searching and some searching algorithms. Some of the goals for this unit and when reviewing this PowerPoint slide deck are as follows. We want to understand what the problem statement is when it comes to searching, and what it is we are searching and what we're searching for. So we need to make sure that we have a well-defined problem before we can continue with defining and using algorithms correctly. We're then going to look at time complexity analysis and efficiency of a couple of different searching algorithms. This is a concept we're going to revisit throughout the course. Right. Within computer science, there are two really important problems. These problems are encountered in a whole bunch of different applications, and they're also a great testbed for the investigation and exploration and analysis of various algorithms and algorithmic schemes. Sorting is a common problem where we're given a list of items and the goal is to rearrange them into some order, some sorted order. Searching is we're given a list of items and we want to identify whether a particular value or a particular item exists in this list. Again, some key questions you want to answer before searching is what is to be searched? Right? Are we looking for numbers? Are we looking for text values? Right? Are we looking for graphs? Right? How large is the set of elements to be searched, as this is going to have some time complexity implications and certainly some runtime implications as well. Is there any sort of order imposed on the data? Right? Is it in some sorted order already? Right? Is it in some graph structure? Right? If we have some idea of the ordering of the items in the list, we might be able to search the items in this list or in this structure more efficiently or effectively. Again, learning about searching and learning about sorting not only helps us to better understand these specific problems, but it provides a great testbed for the investigation and exploration of a number of different algorithmic schemes, many of which we're going to investigate in this class. One of the most basic searching algorithms is sequentially searching a list for a particular item or object. So if we have a Python list or something like an array, and we want to perform a linear search, what we simply do is start at the beginning of the array and then check the first item to see if that's the item we're looking for. If not, we are then going to move to the second item in the list and compare to the item we're looking for. And we'll proceed in that fashion sequentially until we find the item we're looking for, or we hit the end of the list and we did not find the item we're looking for. As far as time complexity analysis, we have a best case scenario, we have a worst case scenario, and then we have all of the cases in between. Best case scenario, we find the item right away. Best case, that's going to take approximately a constant number of operations, right? A constant number of computational steps. Worst case, if we have a list of size n, it's going to take approximately n computational steps, or proportionally speaking. Right. Again here, best case, we will have constant number of operations, right? Proportionally, we'll call this big O of 1. Worst case is going to be big O of n. Average case, if you were to take the average over all the cases, that is, the case where the item we're looking for is in the first spot, the item we're looking for is in the second spot, right? The item we're looking for is the third spot, right? And we add up all of the computational steps associated with all of those different cases, right? And we average them out. We will still get an average case of n. So, best case, big O of n, worst case, big O of n, average case, big O of n. So can we improve upon this? Well, the answer is yes. If there's some sort of order imposed on that list and we can leverage that understanding, then we can employ more intelligent algorithms. In this slide deck, we investigate a very clever algorithmic scheme referred to as divide and conquer, applied in this problem scenario. The result is an algorithm called binary search. I encourage you to investigate this algorithm in the subsequent time complexity analysis, and you'll see that we get an improved time complexity of big O of log of n. All right, thank you for joining me in this video short, and I'll see you in the next episode.